In this lecture we'll talk a bit about more advanced grid applications and how you can send these to the grid. So we'll talk about the grid gate, which is something that we haven't treated yet, and we'll talk a bit more about the sandbox. We'll also give a number of practical examples for you to run more advanced grid jobs. It is advisable to compile your programs on the user interface machine. Many grid nodes have similar environments, and the chances of your job running on a remote worker node are larger when your program is able to run on the user interface. So many people will be using something like Ubuntu or another Linux distribution, and what you compile on those distributions might not necessarily work when you run your stuff on the grid. We will show you an example to submit a script with your application and run it on the grid. This will be a shell script. You can also execute any Unix command in it. In the next lecture we will show you how to execute your own binary program on the grid. The executable will be sent along with your job submission. This can be done with when the executable is not too large, so anything less than 10 MB. And then you can put it in the input sandbox in the job description, as we'll show you later on. The program itself will be executed by a simple shell script called a wrapper, and there are several reasons to wrap the call to your executable within a script. One of those is that this is more flexible. By using the script parameters you can more easily specify and redirect your input and output. In short, this script provides the correct environment for the execution of that binary. So another thing is that of course a valid proxy is required. Remember to start your grid session if your proxy has expired. If you don't know how to do this, check the previous week's lectures. So let's first start with the grid gates. The CEs or compute elements that we talked about are often referred to as grid gates, and we've seen these specifications already in one of the lectures before, where we used the LCG info sites command to list various attributes of the clusters that we can submit to. So here you see an example of the output or part of the output given by the LCG info sites command, and this is actually the last line or the last column of this output. And here you can see the complete specification of the grid gate. It starts by specifying the grid host name, so the creamce2.gina.sara.nl, which basically is a host name, it's any other. Then you can also find the port, which is in this case 8443, the grid gate type, which in this case is cream, the resource management system behind it, which is here PBS, and the queue name, which in this case is short. And what you will often see in the output of LCG info sites is that one site has multiple grid gates. And this is done to be able to redirect specific types or specific demands in the JDL to specific pieces of hardware within one computing element, so within one cluster. It basically just gives the maintainers of that cluster another handle on moving particular jobs to particular hardware. So another thing is the in and output sandboxes. And remember that your home directory and the rest of your environment is actually not available on a grid node. So you need to specify these files, if you need them, within the JDL. So you specify your inbox sandbox by basically writing out the stuff that you want to have sent to the worker node. In this example, the path to the file and the file name. If the JDL lives in the same directory as the files that you want to be sending to the worker node, you can just list the file names. You don't need to give the entire complete path. The output sandbox specifies all the files that you want to retrieve from the worker node. In this case, the script.out and script.error. So if you know which files you are creating, and again they are less than 10 megabytes, you can ask the WMS to retrieve those files for you. Okay, let's take again a look at the way that jobs are scheduled on a grid. We have the WMS as shown before. We're going to just submit a bunch of jobs from a number of users, and the WMS just schedules these on the different clusters and keeps track of the status of their execution. Okay, let's take a look at an example of submitting a script to the grid. And this is the environment that you're familiar with. This is just a virtual machine that we shot it from. So let's open up the script.sh file. And to explain some of the commands that we have here, the set-x activates debugging. Basically it prints every statement before it is executed, and the set-e specifies that if an error occurs, the execution of the shell script will stop. So the last thing that you see is the error itself. So the remainder is actually quite similar to what we've seen before. We echo the date, we print the host name, we print the current working directory, and then we sleep a bit. So now we need to change the JDL, so the job description language. So first thing that you want to adjust is the executable, which now should be the shell. And the shell will actually get as an argument the file that we just edited. So the working directory that we're going to land in on the work node will directly contain this script.sh file, because we can specify that in the input sandbox. We want to redirect the standard out and standard error to two files, which in this case will be script and .out or .error, and we're going to specify the input sandbox as well. So just add another line for the input sandbox. And again, these are the files that are going to be sent to the worker node and are going to land directly into the directory that the executable will also be executed in, which in this case is the argument of this JDL, which is the script.sh file. So we also want to change the output sandbox to the script.out and script.error. And the remainder stays pretty much the same. The only thing is that we now also want to specify the time that is needed to run the application, which is probably quite short. And this can be used to land, for example, in different queues. So if you have a really long job, then you also want to land in a queue, so get to a CE element, so a compute element, which allows you to run for a longer period of time. And here actually the 100 that we're going to specify is in minutes, not seconds. So the parameter that we need to set is the glue CE policy max. That's the for walk clock time. That's the maximum time you are allowed to run, and that should be over 100 minutes. And that should suffice. So let's clean this up. And then we can just save this. Right. You want the script that you're going to send to be executable. So that's what we're changing over here, and we can now just see what the script actually does once it is executed on the worker node. And this is something that you can test within the VM. So this is just the same as it would run on the worker node itself. We're going to redirect the output to script.out, and as you can see, it does exactly what we thought it would do. It echoes all the commands, shows us the date, prints the host name, sleeps for a bit, and exits. And there you can see that the standard out was redirected to a file. Now we can also make this execute on a grid worker node, and we will use the glide WMS job submit command for that. We specify the delegation ID, which is the same as our username if you created the proxy correctly. And we will specify the job IDs file to contain all the identifiers of the jobs that we are going to submit, and we give the script.jdl file. Right, this is the identifier or the link that we get, which has all the information in it, and we now simply have to wait until our application is executed. Through the magic of editing, we can directly retrieve the job output. This of course takes some time. So let's check the status of the different jobs. And we specify the file that has all the job IDs, and there's 3 in them, and the last one is the one that we're interested in. We can see it's scheduled, and we now just have to again wait for more output. As we can now see, it's done, and we can retrieve, or we can see here that it's done again, so basically reflecting the same information, and we can now retrieve the outputs as we have specified in the JDL. You can specify the directory where you want to be placed in. Let's use the current directory, and we give the same job IDs file, and we want to have the output for the third one. And this is the current directory that the data is located in, so subdirectory of where we are now. And as you can see, if you take the error file, this is pretty similar to what we've seen before, and the same goes for the standard out. And this is the host name where it was executed, the directory on the host where we landed, and there's the time and date as well. And that's it. This is the job submission using a script file.